Okay, so here we're asked to find the probability of x being in one interval or another interval given by the range of values here. So the boundaries around each interval are given here. And you'll notice that the intervals overlap. So as before, you have to compute the probability of x being in interval 1, then compute the probability of x being in interval 2, add those two probabilities together and subtract from that the probability of x being in the overlapping region. So I'm going to do that here again. So the values have changed, so mu is 16.2, the standard deviation is 10.53, x1 is minus 16.06, x2 is 33.52, x3 is 29.68, and x4 is 50.48. Okay, and I'm just going to find the overlap is between 29.68 all the way to 33.52. Okay, so let's see where those values are. So it's from, I'm just going to call this x, xo, and xo again for overlap. So it's 29.68 all the way down to 33.52. Okay, so that seems right. Okay, so the z-score corresponding to the first x value is not on this table, so what I have to do is find it in some other way. So if you remember, there is a supplementary table that was emailed to everyone. Let's see where I put that here. Oh, there it is. Okay. So the value of z that I'm looking for on this table is equal to 3 minus 3.06. Okay, and to find the, if you want to be consistent with what you've been computing so far, to find the values that are lower than minus 3.06, because again, look, this is positive, I have to subtract 0.9989 from 1. So 1 minus 0.9989 is equal to, let's see what this is, it's 0.0011. Okay, and the so I'm just going to leave this table for a bit. The second z value that I'm interested in is equal to 1.64. Okay, so I'm just going to put in 0.9495 here. Okay, the other value I'm interested in is 1.28. So again, I just have to find it here. 1.2. Oops. 1.28. And the area associated with that is 0.8997. And to find the area corresponding to 3.26, I go back to my supplementary table here, 3.26, it's 0.9994. Okay, so I can just find the corresponding values for the overlapping region as well. Okay, so to find the total area, I add up these two values and I subtract. So this is the probability of ending up in interval 1 from minus 16.06 to 33.52. This is the probability of ending up in area 2. Wait a second, that doesn't make, hold on a second, there's something wrong here. Well, I guess it sort of makes sense. And this is the probability of ending up in area 3, so that's the total value I end up with. Now let's hope this is correct. Okay, so it was correct. It just looked a little odd, but that's exactly what the area is. Now the next question asks you to find the score corresponding to the 94th percentile in the population. Okay, in order to do this, you need to find, so the 94th percentile means 94% of the area of the distribution is below this score. So what I'm going to do is manipulate this, in the left window, the graph that's on the right, until the area is equal to 0.94. Okay, the z-score I'm looking for is 1.5548. Okay, so essentially what you have here is a z-score, your mu, and your standard deviation. So you have to solve for x. So what I'm going to do is do that on paper here. So okay, so the value I get is 4.99.